Hi, welcome to part 3 of this series on controversies in physics. In part 1, we have confirmed that the gravitational attraction between two bodies depends on the masses of both bodies. We also learned that Einstein's entire general theory of relativity rests upon a misconceived foundation. In part 2, we have further proven that a celestial body's center of gravity has wrongfully been assumed to coincide with its center of mass. In this video, we will be looking at an experiment, the interpretation of which changed our entire perception of nature. What has never been disclosed before is how Einstein used the experiment to serve as the foundation upon which he built his entire relativistic theory. This is Benoit Launier, the black sheep of physics. So without further ado, let's get on with this discovery. Welcome back. It all started by a battle of the minds between Sir Isaac Newton and two other physicists, Christian Huygens and Robert Hook. At the time, Newton was performing experiments on light. He envisioned light to be made up of infinitesimal particles traveling at tremendous speeds. He called them corpuscles. He pointed out that, while we know that sound waves are able to bend because we can hear a bell ringing from the other side of a hill, the hill prevents us from seeing the church tower in which the bell is ringing. Huygens and Hook did not share his opinion. They insisted that light propagates as waves in a manner comparable to that of sound via our atmosphere. The problem then shifted towards figuring out how light can reach us from other stars. From 1878 until 1881, a German-born U.S. physicist by the name of Albert Abraham Mitchellson built a sort of interferometer he believed could prove that light travels in space as waves, via some kind of medium. So the experiment was all about detecting this medium. Mitchelson's interferometer consisted of two arms, P and Q, of identical lengths, made at right angle one to the other. The light from a sodium flame A was fed through a lens B and directed onto a half-silvered mirror M1 used as a beam splitter which sent a ray of light to each arm. One ray was transmitted through the half-silvered mirror M1 and made to travel along arm P to be reflected off of mirror M2 and back. The other ray was reflected off of the half-silvered mirror M1 and made to travel along arm Q to be reflected off of mirror M3 and back. The two rays were then recombined by another half-silvered mirror M4 and directed onto an interference fringe grating IF, where their differential arrival time could be observed. After countless trials, Mitchellson remained perplexed. His experiment failed to return any meaningful results. In 1887, with the help of the U.S. physicist Edward Williams-Morley, the instrument underwent significant changes. The arms of the instrument were considerably lengthened with series of small mirrors bouncing the rays back and forth before recombining them. The interferometer was designed to measure the difference in time the two rays would take to travel along their respective arms and back, DD being one arm and EE the other arm. The observations were performed while rotating the entire instrument 90 degrees upon a vertical axis from the position where one of its arms would be aligned with Earth's motion in its orbit around the Sun until it would reach the position where its other arm would be aligned with Earth's motion. Yet, no matter what they tried, all of their attempts remained inconclusive. From 1902 until 1904, Morley, unconvinced, teamed up with Dayton Miller, producing ever-increasing interferometer sizes. Still, their efforts were in vain. After Morley had given up, Miller continued experimenting until 1924, at which point he finally abandoned. All along its 43 years of trials, the experiment never at any time produced any kind of trustworthy results. The whole endeavor turned out to be a complete failure. Here is an excerpt extracted from the Encyclopedia of Physics by Rita G. Lerner and George L. Trigg. And I quote, "The Michelson-Morley experiment. One of the most famous optical experiments ever performed. This attempt to measure the relative motion of the Earth in the luminiferous ether gradually became as a notorious failure that was widely supposed to have prompted, if not caused, the advent of relativity theory. First conceived and performed in the 1880s, repeated and polished in the early 1900s, and then elevated, repeated, and finally completed in the 1920s, the so-called Michelson-Morley-Miller ether drift experiment gained a reputation beyond its character as a test in physical optics. It became a celebrated part of the rationale for and the debate over Einstein's ideas of 1905 and 1915. Despite many personal tribulations, Mitchellson and Morley made ready their apparatus in June 1887 for what would become the classic experiment. The new optical parts were set atop a massive stone slab mounted on an annular bearing floating on a circular bed of mercury. This apparatus was built upon a brick pier in a basement room close to bedrock foundation and carefully protected against mechanical and thermal disturbances." Unquote. A Dutch physicist by the name of Hendrik Antoon Lorentz, obsessed with rescuing the experiment, came up with the assumption that, perhaps, the arm, the one aligned with Earth's motion, might be compressed due to its motion through the ether. Here is one of his excerpts to that effect. And I quote, "Subsequently, Mitchellson took up the investigation anew in collaboration with Morley, enhancing the delicacy of the experiment by causing each pencil to be reflected to and fro between a number of mirrors, thereby obtaining the same advantage as if the arms of the earlier apparatus had been considerably lengthened. The mirrors were mounted on a massive stone disc floating on mercury, and therefore easily revolved. Each pencil now had to travel a total distance of 22 meters. Now let me repeat this one more time, because this is the true origin of Einstein's relativistic theory. Each pencil now had to travel a total distance of 22 meters, and on Fresnel's theory, the displacement to be expected passing from the one principal position to the other would be 0.4 of the distance between the interference fringes. Nevertheless, the rotation produced displacements not exceeding 0.02 of this distance, and these might well be ascribed to errors of observations." Unquote. This excerpt was extracted from the book The Principle of Relativity, under the title Mitchelson's Interference Experiment by H.A. Lorentz. When I first read Lorentz's excerpt, I felt sort of confused. A typo error, perhaps, because Mitchellson, the instigator, constructor of the instrument, and performer of the experiment, clearly stated that the pencils of light of his interferometer were 11 meters each, not 22 meters each as Lorentz described. In 1895, and again in 1904, Lorentz came up with an equation, transformation that is, which, supposedly, would shorten the arm of the instrument by just the right amount to compensate for the result Mitchellson and Morley were expecting, but were unable to corroborate. Therefore, using Lorentz's equation, I've decided to verify if, at least, it compensates for the should-have-been differential time expected. Confirming my suspicion, Lorentz's equation only compensates for half of the anticipated difference, that is, 1.833 by 10 to the minus 16 seconds, instead of 3.666 by 10 to the minus 16 seconds. This exposes the guilefulness of the conjecture and the equation Lorentz fabricated, duping himself using false measurements. In 1905, 1 year after Lorentz had last published his transformation, Einstein revealed his special theory of relativity, claiming the Michelson-Morley experiment as the endorsement to his theory. And I quote, "In one of the most notable of these attempts, Mitchellson devised a method which appears as though it must be decisive. Imagine two mirrors so arranged on a rigid body that the reflecting surfaces face one another. A ray of light requires a perfectly defined time t to pass from one mirror to the other and back again, if the whole system be at rest with the ether. It is found by calculation, however, that a slightly different time t' is required for this process if the body, together with the mirrors, be moving relatively to the ether. And yet another point. It is shown by calculation that for a given velocity v, with reference to the ether, this time t' is different when the body is moving perpendicularly to the planes of the mirrors from that resulting when the motion is parallel to these planes. Although the estimated difference between these two times is exceedingly small, Mitchellson and Morley performed an experiment involving interference in which this difference should have been detectable. But the experiment gave a negative result, a fact very perplexing to physicists. Lorentz and Fitzgerald rescued the theory from this difficulty by assuming that the motion of the body relative to the ether produces a contraction of the body in the direction of motion, the amount of contraction being just sufficient to compensate for the difference in time mentioned above. Comparison with the discussion in section 12 shows that also from the standpoint of the theory of relativity, this solution of the difficulty was the right one." Unquote. This excerpt was extracted from the book Relativity, the Special and the General Theory, written by Albert Einstein. Einstein's excerpt clearly reveals where he took the idea for his slowing down of time theory and how he came up with the equation. It also tells us that he never verified Lorentz's equation. Coincidentally, Einstein's slowing down of time equation is a carbon copy of Lorentz's fabricated equation. Shortly after releasing his work, Einstein was confronted with the plagiarism. He insisted he came up with the equation on his own. It was imperative for the equation to be recognized as genuinely his, because it was a foundation stone upon which he built his entire relativistic theory. In any case, the Michelson-Morley failed experiment does not offer any grounds upon which a theory can be built. The origins, the beliefs of the physicists of the time, the venue, as well as the many other illogicalities that plague the experiment, are extensively detailed in my book, The Universal Physics Theory, 5th edition. Thank you for watching. I hope it was informative. And if you liked it, please share it with others.